Welcome to my YouTube channel. Please subscribe, share, download, and comment. Once more, you are welcome.
Greetings, my members. I wish to welcome you to my today's video, which I essentially intend to major on constructing a circuit and lighting up circular LEDs in a circular manner. And remember, as it has been our culture, we are doing that from an online application by the name Tinkercad. So without wasting time, let's delve into our today's core business. So I believe that you're already in your account, that is the Tinkercad account. So from the Tinkercad account, you open a new circuit, then you'll be redirected to the working space. That is where I am right now, and we start by creating the title. You can make the title, or rather choose to ignore. It will bear no effect. That's good to make your work be understandable from a glance. So let's start our core business of the day. So I'm going to start by pulling out components to our working space, and the first component is the microcontroller that will be used for the controlling the lighting process of our LEDs. So the next component or rather the apparator, I think it's a component in a way, is this breadboard that will be used for the connection of the various components that are going to be used in the construction process. So the next one, we have LEDs, and I want to use 6 LEDs. So I want to pull 6 LEDs into my working space. 6 LEDs, already 5, already 5, we need one more. So these are my 6 to achieve what I want to achieve today. So I believe that design is not that ugly, and we can go by it. So these are my 6 LEDs, and I need to have them having different colors. So I will change that color. I'll change their respective colors. But before that, I need to get the last component, which is the resistor, which will be used for the protection of these LEDs against excess current that will be generated by our microcontroller. So this is our resistor there. So it needs 6 resistors, but we can just use this one. You can change its parameters, then do what we call photocopying, and assign each of these LEDs with a copy. So let's now proceed to change the colors of these individual LEDs. You can have the first LED being red, then the second one can change it to blue. Remember the process of changing the color, or rather any parameter in any component. You just click on it, then you have this block popping out. Then from the block you can change any parameter you want to on a given component. So you can make this one, change the color for this LED to green. You can make this one yellow. Let's make this one to be yellow. Yeah, yellow is okay. So now this one being what, which color? You can repeat blue. I want my design to be smart, to have bright colors. So that is blue. You can have the next one. You can repeat it. You can reuse green. So we have to change to the colors. Now the next step is to want to supply a copy of resistor to each cathode of the individual LEDs here. So you can start by first changing the parameters of this resistor, that is its value, resistance value, and also the units. So you can use any value between 220 and 330. So I personally will use 220, but you can use your own value between 220 and 330. It will work well. So you also need to change the unit to be in ohms. So we are done with that. I can copy, I can make a copy. So then I pull this one and it's applied to each of the colors. Remember, colors I said is the straight line. If you click on it, it will show you which one is the color, which one is the anode. So I have supplied the first one. I need to bridge this gap that is here. So I've bridged that gap. I also need to apply another resistor to my secondary blue LED. Can have it there. Can see there is connection. We don't have any discontinuity. So for this one, we also need to apply it with a resistor in a similar manner. For this one, the same. Maybe okay, I can make some adjustment there. Sorry, I can pull it back there. Then I can connect this one this way. Yeah, I have bridged that gap. Then I also need to supply another resistor for the first blue LED. There, and bridge that gap. Then the last one is the first LED, is the red LED. So it is there. I bridge that gap. So we have already supplied our cathodes with the resistors and I connect them to the ground of my breadboard. So the next step can do the powering, can serve my breadboard with the neutral or the ground. So that is the ground. We have connected the ground there. It's okay. Can now proceed to give it some voltage. So we are going to give it 5 volts. I still use 3 will work for my design, but usually you may not require to use those resistors that you can test to see if they are working. You use 3.3, which is supplied from this port. They will still work, but you may be required to maybe reduce the values of these resistors or totally omit them. So we have that is okay. We now need to connect the individual anodes to our microcontroller, which is the Arduino. So remember, I've said that this Arduino will be used to regulate the pattern by which these LEDs will be lighting up. In other words, this is like the memory. It is the remote control of the lighting process of these LEDs. This chip here, this IC, it is the brain of everything, of what you want to. It's the brain of our entire circuit. The manner in which you want these LEDs to light up will be determined by this IC. So you can proceed to do the connection. So then, before we proceed, I also added that you can use any of these digital pins from pin 2 all the way to pin 13. You can connect it. You can use any of them, with the exclusion of the first 2 and the last 3. Those exclusions actually are assigned or rather preserved for special applications, especially in scenarios where we are involving serial communication. So we can now start our connection. So we can have our red LED being connected to our pin of choice. Our pin of choice can use pin 13. I can use that. Pull down for you to see. That is pin 13. It's okay there. Can proceed to blue LED. Connected to pin number 12. You can use another pin of your choice, as long as you remember to reflect that in the code. So you can go to before that I think I need to change the color of the cable so that it may match the LED, or you can use any other color of your choice, but I prefer using a cable that is similar in terms of color with the LED. So you can proceed to the green LED, green LED, green LED. That is pin number 11. Pull it. Sorry. Make this one green. That is green. Then go to yellow. Yellow. Let's connect it to which pin? Pin number 10. Pin number 10. Then you can adjust the outlook of the cable. So you have it that way. You can pull it a bit this way and change that color to yellow to match the LED. Then proceed to the secondary blue. Secondary blue, can tap it from here, then can drive it up, then connect it to pin number 9. Digital pin number 9 is where we have connected our secondary blue LED. Secondary blue LED. Then the last pin is this green LED here. We have that green LED. And as we connect pin number 8, we're connecting to pin number 8. Pin number 8. Remember the color? The color is green. You can use any. So I have connected all my anodes to my digital pins from 13 all the way to 8. So we are done with that connection. Now the next step that is remaining is to connect no, not connect, but to prepare the code for this circuit, the code that will be lighting these LEDs in a sequence that we want, that is from red all the way with the other resistors back to the first red. So we are going to do the coding in the second part of this video, so stay tuned as we get to part 2 for the coding. So thank you for now.